The last one, this is number 10 from skill check number 2. Again, I've already entered the data into my table, stat edit, right? So this is the data. It says the following data pairs give U.S. average annual public college tuition, where X represents the years after 1997 and Y represents the tuition in dollars. Part A says find the best fitting line for this data. That is literally just asking you find the linear regression. So we click stat, calculate. Linear regression is number 4. We click enter. Remember, store into the regular equation. Older calculators, you're just clicking vars. And then we go y vars, function, y1. That's what we want to store it in. And we click calculate. Boom. There's our linear regression. Okay. Make sure that it makes sense with the data, right? The slope is positive. It's got a really big y-intercept. Okay. That makes sense with the data because if you look, the y values are going up as the x values are going up. So that means why we have a positive slope. So then find the line for the best fitting data. I would say y equals 101.32x plus 2,236.61. That's what I would write in for A. Okay. For letter B, we're going to have to use a graph. So according to your model, what would your average or the average public college tuition be in 2014? Well, the first thing is we need to decide how many years after 1997 is 2014. In order to find that, we just take 2014, we subtract it from 1997, and it gives us the x value that we're looking for. So in this case, it's looking for x equals 17. So now let's go to our y equals. Our equation is in there. That's awesome. Okay, sorry, 6 was from the last one. My plot one is on. You can have it on, have it off. It's your choice. Having it on shows you if your data is good or not, so I like to have it on here. And then let's build our window. Okay, so the window that I had built in here was for an old question. So we need to rebuild this window. The lowest that we go is year 0. Okay, but whenever we're graphing data, I like to be able to see the y-axis sometimes if we're close to it. So I'm just going to go -2 just so that I can see the y-axis. X maximum. The number that we're going to plug in is 17 because we calculated that number as 17 years after 1997 is 2014. So our X max has to be bigger than 17, so 20. Okay, Y scale, counting by 2 would probably make that look nice, so why not count by 2? You could just keep it at 0, you could count by 1. Literally, the scale doesn't matter, guys. I'm just care about the X min, X max, Y min, Y max, okay? Y min, so if I'm looking at this, 2,271 is the lowest Y value. Okay, that's literally the lowest one. So I'm gonna start at like something pretty high. Let's just start at like 2,000 even for our Y min. Y max, it goes up to 2,928, but remember we're going for an X value of 17. That's only X equals 6. So we're gonna have to go a lot higher than 2,928. So let's go to like, I don't know, 4,000. That's just a complete guess. This I'm definitely counting by 0 because the difference between 4,000 and 2,000 is pretty big, okay? So I don't want all those tick marks to show up, especially if you're counting by 1. So now I'm going to click graph. Okay, sweet. We have some pretty good data if we look at this. So now we could click trace. Okay, right now we're on the plots. We don't want to be on the plots. We instead want to be on the graph, so I'm going to click down. Now I'm on my linear regression. You can see that right here in Y1. And then I want when X is 17. So I type 17, I click enter, bam. Okay, so tuition will be about $3,959.07 in the year 2014. So we want the Y value right there. The next part C is saying, according to the model, in what year would public college tuition be expected to be $8,000? So that's telling us, well, now we know that the public tuition is $8,000. That's a new Y value, right? Because tuition is our Y values. We can see that from the graph. So then we go to window. Now we literally know that our Y max has to be bigger than 8,000 because we're plugging in 8,000 into the equation. So let's go 9,000. Okay. 4,000 was at 17. Basically, 4,000 was at 17, so our x max is going to have to go out pretty far. I'm going to say 50 years, okay? Again, total random guess. I'm going to turn off my x scale so I'm not looking at it anymore. No more tick marks on my x. But the 50, that's a total guess. I'm just saying it's probably going to go out pretty far because at 17 we were only at 4,000. We need to double that. Okay, so now let's graph it. So I didn't quite make it, right? So that means we just need to pop out the window a little bit more. So instead of 50, let's go to 100. Okay, it might be overkill, but that's okay. We should definitely see it now. Okay, there it is. Awesome. So now we can click second trace. We need to find that intersection to find the answer. Intersection, second curve, enter, boom. Okay, so 56.88 years, the tuition is going to be about $8,000. So the question was, when will college tuition be expected to be $8,000? So you could say 56.88 years, right? But that's not, tuition doesn't change in the middle of the year. So I would probably say 57 years. Okay, 57 years after 1997. So what you should do then is you should go 1997, add 57 years to it. So 2054, it's projected that tuition will be $8,000. Okay, so this would be your final answer, 2054. So if you guys have any questions on that, email me, Canvas message me, do what you got to do. But be ready for these tests, okay?